Hello my dear students, how are you all? Welcome back to our YouTube channel Diksha Karnataka. I hope all of you are doing very good, right? Today is the day 18 of our ongoing series, which is 60 out of 16 KCET Mathematics in 100 days. As you know, we are continuing with our chapter Continuity and Differentiability. Today is the part 5 of this chapter. So far we have discussed so many things. We have talked about continuity, we have talked about limits, we have talked about differentiability. If you want to have a proper recap, go watch the previous session. In that session I have done a recap of all the sessions as well. Okay, so in the session today what we're going to do is we're going to talk about differentiation when the question is given in the form of parametric, when the question or when we are asked to find what second order derivative of the questions. Okay, so for any function when we are asked to find second order derivative, third order derivative, most of the time they don't ask us third order derivative, but we'll also see what can we do for third order derivative and so on. Okay, so without wasting any time, I hope you are ready with your pen and paper. Let's start with the session. Okay, let's get ready, sir. All right, so coming up next is first thing is what we did in the previous session. So as you know, I recap your previously done session, sir. What was it, sir? So we talked about in the previous session for differentiation with regard to what, sir? First thing was bacha ITF. First thing was ITF. Okay, we talked about what? For example, if I have to take some function, tan inverse of x is given as y. What is my y dash? My y dash is simply 1 upon x square. Okay, if I have a question where I have y equals to cot inverse is given and asked what? Again y dash. How will this be? This will simply be minus 1 upon 1 plus x square and so on, right? So we talked about some ITFs, all the ITFs actually, we have 6, right? So we talked about all the 6 ITFs. Next, what bacha? We also talked about logarithmic functions and exponential functions. Okay, we talked about the graphs, the features of them, how the domain range looks like, how they are inverse. We also talked about the graph that we take about what you call, we take the log graph, mirror image about what bacha? About y equals to x line. Mirror image about y equal to x line. When we do that, okay, when we do that, we used to get what? If I take logs mirror image about y equal to x line, we get what? We simply get this as inverse, which is nothing but exponential function, right? We learned about the standard form, then we solved numerous questions on all these 3 categories. I hope you all solved it. If you have not solved it, go ahead, watch the video and solve those questions. They were very good questions. They had combination of all the different type of functions. So I really hope that you have solved all the questions from the previous session. Now moving on to this session, as I said, what we have coming up today's session, we have parametric form. What is the parametric form? So usually, if you remember, what used to be the question when we used to solve? So if we have y equals to sin x, then they used to ask what bacha? Find y dash. What is y dash, sir? Y dash is dy by dx or first derivative, okay, or simply differentiation. If you don't want to say first derivative, simply differentiation of the function y. Okay, so how will I write this? Y dash will be equal to cos x, sir. Y dash is equal to cos x, sir. But if there is a situation when I have y equals to sine, let's say t, and x is equals to, let's say, cos t. X is cos t, y is sine t, x is cos t. Let me rewrite that part. Okay, cos t, sine t and cos t. Then and they're asking what? Again same thing, dy by dx or y dash, dy by dx or y dash. Then how will you solve it? So how will you do it? No, you will take the first function. Is there an x in this function? No. So you'll solve this function with respect to, I'll find the derivative of the first function, the y with respect to t only. So you write like this, d by y dt for the first part, and same way you'll do for x, dx by dt, and what you're gonna get? You'll end up with this value. So if you apply to this, differentiation of sine t with t is how much bacha? Simply cos t, right? And differentiation of cos t with t is how much bacha? Simply minus sin t. What is the answer here? The answer is minus cot t, cot of t. Okay, so for the function given as, this is just an example I've taken, for the function given as y equals to sin t, x equals to cos t, I have dy by dx equals to dy by dt upon dx by dt given as cos t by minus sin t. I hope this is clear. Okay, so this is our answer. Now let's just check back what they've written here. Okay, so sometimes x and y both are expressed in terms of a third variable. I wrote no third variable as t, which is usually called as a parameter. Parameter is the variable, the third variable, which is t in this case. What's the parameter? T in this case. Okay, thus a relation expressed between two variables x and y in the form of xft ygt is said to be parametric form with t. Okay, so whenever we have the questions or the functions given in this parametric form, how do we deal with it? Okay, this is incorrect, this dx. Okay, I hope this is visible. If it is not visible, let me rewrite it. So simply this is dx. Okay, dx by dt, yes. All right, sir. So using this formula, dy by dx can be written as dy by dt upon dx by dt. All right. Okay, let's move on to the next set of property. What we have here again, sometime in this property, what happened? What if? So what we did in the previous question, if you remember, we use a differentiation across only the parameter t. But what if we have a situation where we have to differentiate with respect to what? Another function. Whenever I have to find differentiation of a function with respect to another function, please check here. With respect to another function, I have to find a differentiation of a function, okay, with respect to another function. For example, you see in the coming question like this. I have a function over here like this. I have to differentiate with respect to this function a sin t. Whenever this kind of situation arises, then what we do? Follow the same approach. First, what we do? Whatever is the variable of that particular function, we differentiate with respect to that only and write it like this. So for example, the function y equal to fx and z equal to gx. Please check here. Y equal to fx and z equal to gx. Both of are the function in which variable? X only, sir. X only. So what I did? Differentiated y with respect to x, so dy by dx. Please check here. Differentiated y with respect to x, so dy by dx. Same way, differentiated z with respect to what? X only, with respect to x only. So I'll write it as dz by dx. All right. So now what we do is we take the relation here. Please check. We take the ratio dy by dx upon dz by dx. Why, sir? Because we are looking for what value? Dy by dx. We are looking for what value? Dy by dx. I hope this is clear. Okay. That's all is written here for you. I'll read it out anyway. Till okay. So okay, another variable. Now we will, okay, so we talked about only with variable respect. Okay, the parameter is present, but what if this, a function is asked to be differentiated across another function, then we use the same approach. Okay, all right. So what we do, I'll repeat, we take the variable which the function is present. Okay, let's say sin x. So x is the variable. Okay, or log of x is the variable. So whichever is the variable of the function, we'll find the differentiation across only that variable and take the ratio like this to get the result of dy by dx. We'll see in the problems. Sir. Let's check this out. Let us check this out, sir. Okay, find dy by dx. If x is equals to a cos t plus log tan t and y equals to a sin t All right, sir. So what we have to do? First, let's do for y. I hope this is visible. Y equal to sin t is visible. Okay, it's not sin t, sir. It's a sin t. Okay. So what we are looking for, bacha? First thing I said, dy by dt will find. What will find? dy by dt, sir. Yes, sir. How much we get, bacha, here? A is a constant, will remain as it is, and sin will become what, bacha? Cos t. Forgive me. Cos t. Okay, the first part is done. What about next part? I'll do for x also. So I'll get what, bacha? Please check. I'll do x over here if you don't mind. I'll do x over here. 1 second, just a second. Y part is done. Let me do for x. So x is given here only. So I'll continue from here. So dx by dt I will do for this case. Dx by dt. Yes. For this I did dy by dt. For this I'll do dx by dt. What I'm going to happen? So I'll keep the a constant as it is. Okay, please check. Now I'll apply the differentiation inside of the bracket. If I move in, there's a plus sign over here, so I can take the differentiation of these two terms separately. So this will become what? Differentiation of cos t simply minus sin t. Remember this? Differentiation of cos t is simply minus sin t. What about this? I will have to use what, sir? I have to use chain rule. I have to use chain rule. Yes, sir. So plus what next? Log of tan t by 2. So how does that look like? So first I will go over tan thing. It will come down. For logarithmic differentiation is log of x is 1 by x. So 1 by tan t by 2. This is clear? This is clear? Right. What about next part? Differentiation of tan. Differentiation of tan. How much is that, bacha? Secant square x. Remember? Secant square t by 2. Is it over, sir? No. First logarithmic, second trigonometric, and third is polynomial function. T by 2 is also there, right? So that will give me the differentiation as 1 by 2. Now it's complete. Differentiation is 1 by 2. Now it's complete. I have done the similar kind of step in the previous session also. Please check here. I have minus sin t. Over here I'll have 1 upon, this 2 will come here. I can write this 2 here first. This is 1 by 2, no? So this 2 will come here. Tan t by 2 will be what, bacha? Sin t by 2 upon cos t by 2. Correct. Now what about this? Secant square is in the numerator. If it comes in denominator, it will become what? Cos square t by 2. I hope all of you are getting this. Yes. Secant square is in the numerator. If I bring it in the denominator, it will become 1 by secant, which is nothing but cos. Please check here, cos t by 2 and this will cancel each other. Cos t by 2 and this will cancel each other. What I'll have left? A minus sin t plus 1 upon 2 sin t by 2 times cos t by 2. Yes or no? One of the cos is cancelled, so I have only one cos t by 2 left. Okay. Alright, so now let's check this out. Okay. Do you remember this formula? Sin 2a equals to 2 sin a cos b. Sin 2 equals to 2 sin a cos b. So what is my in this case? What is the condition in this case? It's written like this, no? If you recall this, it's written like this: 2 sin t by 2 times cos t by 2. Cos t by 2. If you see this, what will this become? The LHS side will be simply sine of 2 times of t by 2. How much is that? Simply sin t. Please check. Please check. So I can replace this statement. I can replace this statement by sin t by 2. So how will that look like? Please check here. So I will have, what is this? This is my dx by dt, no? Visible, right? This is my dx by dt. So I can write this in the next step. Dx by dt is equals to, what is it? A times of minus sin t plus 1 by sin t. Please don't ask me now why. Don't think why. Because this I wrote it as, this whole thing becomes what? Sin t. I just explained, right? This becomes sin t. Now if you see here, what will this become? A times of minus sin square t plus 1 upon sin t, right? LCM I have taken. What is this going to become? Please check here. This will simply be A. 1 minus sin square is how much, bacha? Identity? Cos square t. So cos square t upon sin t. This is what? This is my what? Dx by dt. What are we looking for? Please check what are we looking for. We are looking for dy by dx, right? Dy by dx, sir. Dy by dx, sir. What is my dy by dx? Simply this, dy by dt upon dx by dt. What is dy by dt? Please check. Over here, a cos, over here, a cos t. So please let's write here, a cos t. What about my dx by dt? Look at here, a cos square t by sin t. A cos square t by sin t. How will this pan out? Let's check. So a and a will cancel, and this cos will cancel one of the cos. Okay, so simply it can be written as 1 upon cos by sin is how much? Cot t will go up, will become what, bacha? tan t. What is it? Tan t. Okay, it is simply tan of t. So what? This is visible, right? dy by dx equals to tan t is my final answer. Let me show you from the beginning. I hope you can see this. Okay, moving on. Yes, alright. Now second order derivative, the second concept which is there for us, I said in the beginning only, second order derivative means if I have, first of all you should understand the differentiation that we write it as dy by dx is simply can be called as what? First order derivative also. Okay, if this is what? Differentiation of y with respect to x, I can call this as first order derivative of y also. First order derivative of y also. Whereas if I go ahead and again differentiate this my first order, I'll get what, bacha? I'll get second order derivative, which is nothing but d square y by dx square. This is called as second order derivative. This is called as second order derivative. And how do we get this? How do we get this? By differentiating the first order derivative. Please understand this. By differentiating the first order derivative again with the same variable. Please check. First variable y, so the function y was differentiated with respect to x or dy by dx. Then I am again differentiating the dy by dx, the first order derivative with respect to same variable x. So that's going to be called as second order derivative. If I keep going on, again differentiate this with respect to dy by dx, I'll get what? So d by dx, I'll get what? Third order derivative. I keep going on, I'll get what? Nth order derivative. So if I have to write what? If I have to find what dnth or nth derivative, how will I write this? Please check. Simply will be dn y upon dxn. This is the expression for my nth order derivative. Whether n is 1, 2, 3, 4, it remains same. dny upon dxn. dny upon dxn. Yes, sir. Okay. So you see written here. Yeah. So q will be d by dx of d square by upon dx square. It's not square actually, but this is basically d by dx of second order derivative. Okay, that's how we read it, d square by upon dx square, but it is basically second order derivative. What is this called as? Second order derivative. Okay, second order derivative. I hope it's clear. All right. Now how to represent this? You can either write it as y dash or y double dash. For the first order derivative, y dash, second order as y double dash, or simply write in this form, no, dy by dx and d square y by dx square. Okay, or you can write it as y1 and y2 also. So y1 is my first order, y2 is my second order, y dash is my first order, y double dash is my second order, dy by dx is my first order, and d square y upon dx square is my second order. I hope this is clear. Let's move on to the problems now, sir. Problems. Today's concept was very limited, not that much. So we'll explore these concepts with the help of problems. Okay. Please check the first question. Differentiate log of 1 plus x square with respect to tan inverse x. Okay. Tan inverse x. Alright, so let's see. So yeah, this is a case where we are differentiating this with respect to another function. Remember, only with the variable we used to do. Now we are doing differentiation of this with respect to another variable, another function, tan inverse x. So again, what we will do? I set this for this situation. What we used to do? So let me just name these functions. Y equals to. Okay, I can't name it y. Let's name some other variable. Okay, let me name it as p equals to log of 1 plus x square, right? Log of 1 plus x square. What about this? Q equals to tan inverse of x. Tan inverse of x. Okay, sir. What they are asking for? They are asking for dp by dq. Right, bacha? Please check here. Differentiate this, the p with respect to q, right? They are asking what? dp by dq, right? And what we used to do, remember this? dp by the variable, the function is defined in x, sir. dp by dx upon dq by dx. dq by dx, very simple. How will I do the dp by dx part? Please check here. dp by dx. How will this look like? Please check. dp by dx will look like over here. I'll take for this. So it'll be simply logarithmic differentiation will be what? Whatever is in the log should come for the denominator, 1 plus x square. Then what will operate? On the chain rule, it will become 0 plus 2x. Simplify this. This will be 2x upon 1 plus x square. Am I right, bacha? Yes. 0 plus 2x is 2x. So 2x upon 1 plus x square. This is my dp by dx. What about the second one? dq by dx. dq by dx. What's my dq, bacha? Inverse of tan. So tan inverse of x cut differentiation. We know this is nothing but 1 plus x square. Differentiation of tan inverse of x is 1 plus x square, 1 upon 1 plus x square. So again what we are looking for? That ratio. Let's use it here. Let's use it here. How I'm gonna get this? dp by dx will be what? Okay, I'll do it here only. dp by dx, please check. dp by dx, please check here. 2x upon this thing. So I'll write it here. 2x upon 1 plus x square. What's the last thing about this? dq by dx, 1 upon 1 plus x square. 1 upon 1 plus x square. 1 plus x square. Something getting cancelled? Yes, sir. This and this. What is left? What is left? Please check. So if I have to write this, I'll write the final answer over here. Please check. dp by dq, dp by dq is given by what? 2x by nothing, only 1 is there. Please check. 2x by only 1 is there. So I get what? 2x upon nothing, which is simply 1, right? What is it? Which option? Option C. Option C is correct answer, sir. Please check. Option C is my correct answer, bacha. Is this okay? Please check. Option C is correct answer. Yes, sir. Can we move on to the next problem? Shall we move on to the next problem? Yes, sir. Let's quickly do it, sir. Okay, we'll not keep the session that longer today, not required. The last few topics are left, we'll complete it quickly and move on. Okay, okay. Now this problem, look at it. If x is given as, so again we have to differentiate another function, exponential function with respect to another exponential function. So this is a different function, this is a different function. How, sir? Please check here. There's a plus sign present here, there's a minus sign present here. The function is different. Now function is different, plus and minus. I have to differentiate what? This with respect to this. How will I do it? First differentiate with respect to, first differentiate y with respect to the variable m. Why, sir? Because operating variable is m in this case. Same way, differentiate x with respect to operating variable, which is m in this case. Okay, so how I'm gonna deal with it? Let's see, sir. So I'll write the first statement here. Over here only I can write. I think that, okay, all right. Let's see. So, okay, first I have to do what? They're looking for what? dy by dx, right? So this will be simply what? dy by dm upon dx by dm. Correct? This is what we get from parametric form when we're trying to differentiate a function with respect to another function. dy by dm upon dx by dm. Am I right? Yes, sir. How will I do it? Please check. Please check. First for this part, I'm going to do dy by dm. How will this look like, bacha? E power m will remain as it is, but I have to again what? Take what? Differentiation of m. How much that will be? 1 only. How much that will be? 1 only. Please understand this, because I'm differentiating with respect to m, right? I'm differentiating this whole thing with respect to m. So if I'm taking for e power m, exponential function remains as it is, and then you differentiate m, will be 1. Same way if I do for this part, I'll get what? Please check. It'll be e power minus m, but another minus 1 will come here. Correct? Okay, correct. And this 2 will remain as it is. 2 will remain as it is. What about this? What about this? When I do for x part, so d of x upon, okay, let me just simplify this step. I'll just simplify this minus sign, okay? So this will be written as dy by dm equals to what? E power m, and this will be minus sign will come here, e power minus m upon 2. Yes or no? Yes or no? And how much is this? Please check. Isn't that the x value? Please check. E power m minus e power m minus e power minus m upon 2, x value. So I can write this as x, similar, very simply what I'm getting here, dy by dm has become equal to very simply x. dy by dm becomes equals to x. So I can write this like this. Okay, same way I have to do what bacha now? Dx by dm. Please check here. Dx by dm. Yes sir. Okay, how will I do it? I'll take from here. So e power m will give me again e power m only, but for m I'll get 1. Over here what I'm gonna get? E power minus m only, but over here what I'll get? Another minus 1 because of the minus m part, and 2 will remain as it is because it's a constant. Yes, simplify this, e power m, and this will become minus, and minus will become plus e power minus m upon 2. Cross check, this value is same as this, so simply y. I'm looking for what value? This dy by dx, which is nothing but dy by dm upon dx by dm, nothing but dy by dm is how much? X. Dx by dm is how much? Y. My answer is what, bacha? What's my answer? Please check here. What's my answer? XYY. XYY anywhere? A. XYY. XYY. I hope this is simple and easy. Yes sir, simple and easy. XYY. Option A is correct answer. Moving on. Third problem is done. Let's move on to the next question. Fourth problem. Differentiate cos inverse of sin x with respect to tan inverse of x. Tan inverse of x. I hope this is visible. This is x, okay? Tan inverse of x. Alright. So same way we'll do, okay? The steps will not change. Whatever is the question, the steps will remain same only. Okay? Alright. Okay. So let's do for again. Let's take this value variable to be p equals to this part cos inverse of sin x, okay, and q to be tan inverse of x, am I right? Okay, how will you do it? I'll show you the steps. I'll not write all the answers, excuse me. I'll show you how to do it. I'll give you the answer, you solve it from your side. Okay, so how will I do it? I had to find what? Differentiation of this. Yes, I've done a similar question before. How will this look like? Simply this, dp by dx upon dq by dx. Don't ask me why, because both the functions p and q are written in the variable x and x, right? So I can write it like this, dp by dq equals to dp by dx from the standard form of parametric. Okay, that's how we take the differentiation of parametric form. Yes, so from here we have this relation. Alright, so you can do the differentiations, cos inverse of sin x and tan inverse of x. I'll tell you the answer. The answer will come as C. The answer will be C. Please check this. Okay, solve and comment your answer. Comment your answer. Okay, not only answer, if you have your doubt also. If you have any doubt also, if you have any doubt, you comment. Okay, all right, let's move on to the next part. Okay, you can solve this, right? P is given, Q is given. Find this expression dp by dx, put it in this for this dp by dq. In this expression, if you put this in this equation, you'll get a result that will come as minus of 1 plus x square. Let's move on. Okay, all right. So now what about this? Over here we have to use some substitution also. Please check. Sin inverse of t upon 1 plus t square, and cos inverse of 1 upon 1 plus t square looks difficult right now. Looks very difficult right now, because we know that sin inverse, to solve this, to be able to solve and find the value of dy by dx, I need what? I need at least this operated on a what? Sine or cos function. Okay, means I need a trigonometric function inside of the bracket. Okay, which one will be applied? If you know that, very straightforward point. If there is a plus sign over here, plus or minus sign, not plus, there is a minus sign over here. If there is a minus sign in place of plus sign, you will put what? Cos or sine based on the situation. Why cos or sine? Because we know that 1 minus cos square theta makes what? Sine square theta, and if the root is applied on this, it will become, root and square will cancel, it will become what? Simply sine. Same goes with sine also. If I put here sine, I'll get this as cos. So I will, whenever I have this minus sign, I use what? The substitution of t as sine or cos. But in this case I have a plus sign. How will I do it? Remember this formula, 1 plus tan square theta is simply secant square theta. 1 plus tan square is secant square theta. So if I put t as tan theta, this root will be cancelled. Please check. If I put t as my tan theta, this root will be simply sec square theta and will become what? Sec theta, right? So that's what we're gonna do. That's what we're gonna do. These things you should know, bacha. Okay. Alright. Just give me 1 second. Let me erase this. Okay, sir. So let's look at the substitution first. First step is taking what, bacha? Taking t as tan theta. Okay. When I do that, what happens to my x? Please check. What happens to my x? X will be sine inverse of tan theta upon sec theta. Don't ask why, please. I just explained you. Tan square will become 1 plus tan square will become root sec square. This will be what? Root sec square theta, correct? Simply sec theta, okay? Simply sec theta. Let's simplify this. X equals to sine inverse of, okay? Okay. Please check here. This will be sine by cos and this will be 1 by cos. So cos and cos gets cancelled. I have what? X equals to sine inverse of sine theta. How much is it, bacha? X equals to theta. X equals to theta. Please check here. X equals to theta. Correct? Sine inverse of sine theta is theta. How much is theta? Please check from here. Theta is going to be tan inverse of t. Tan inverse of t. So I can write this as simply tan inverse of t. Yes or no? Please check. I got x as theta. Simply this will become tan inverse of t, no? Tan inverse of t, right? Yes, sir. Okay. Now what about my y? I'll do for y in this page. So this slide I mean. Y equal to cos inverse of 1 upon 1 plus t square. Y equals to cos inverse of 1 upon root of 1 plus t square. After substitution this will become what, bacha? Cos inverse of 1 upon sec theta. How much this will be? Please tell me. Sec theta will become what, bacha? Not visible, sir. Looks complicated. Okay. Let me simplify it. 1 upon sec theta. Okay. How much this will look like? After this, they will become simply cos inverse of cos theta. Yes or no? Correct, right? 1 by sec is cos theta. So I get my y as simply theta, right? Cos inverse of cos theta is theta. And what is theta, bacha? Please check here. This is going to be tan inverse of t. Please check here. Y is theta is tan inverse of t. Now what is they asking? dy by dx they are asking. This is simply what? dy by dt upon dx by dt. We know that we got both of them as tan inverse of theta. Tan inverse of t will become what? 1 upon 1 plus t square upon 1 plus t square. How, sir? How, sir? Remember this. Differentiation of tan inverse of t with t is how much? 1 upon 1 plus t square, right? This is the formula, no? This is the formula, right? For differentiation of inverse trigonometric function for tan inverse, I get 1 plus t square. So both of them are tan inverse t and tan inverse t. Tan inverse t and tan inverse t. So what I get this as? Cancel it like this. What is my answer? 1. So what is my dy by dx? 1. This is my final answer. Please check. Yes. What is my answer? This is nothing but 1. Okay. Very simple. Very, very simple. Let's move on to the next problem, bacha. Next problem. Which is it? Which is, okay, e power y x plus 1 equals to 1. Then so that this is true. What is this? Can you read this? This is second order derivative. Please read this. Second order derivative is this. And what is this? The square of first order derivative. This is second order derivative. This is square of first order derivative. Okay. Alright. So let's see. What type of function is this? Can you see this from here? This is my implicit function, because I cannot write y directly. I cannot have just y as subject. I will not be able to separate it directly over here. So how will I write this question? Please check. So I will get this as, I'll do the differentiation over here. I'll get this as, so this is first check here. I have to apply what? Product rule. I have to apply product rule. One function is e power y, second function is x plus 1, which is a linear function. So I will write this as e power y differentiation will be e power y, okay, and this will be simply, so looks confusing, let me do it like this. So I'll keep e power y as it is, okay, e power y as it is, and I'll write here differentiation of x plus 1 upon, okay, plus, I'll keep x plus 1 as it is and differentiate what? Differentiate what? E power y. Differentiation of e power y with respect to x. Am I right? Am I right? Yes, sir. Let's see how all this be, bacha. E power y will be as it is, as it is. I'll get over here what? Please check. This will simply be 1, right? Because differentiation of x is 1 and for 1 it is 0. So simply 1. What about this? Please check. This will become, I will write this as e power y, first thing, and then since y is there, I have to write what? dy by dx. Correct, na? E power y differentiation is ey and y is a variable here, so I have to do for y also. What's the differentiation of y with respect to x? dy by dx. I'll repeat. Differentiation of e power y is e power y, and then what chain rule will apply? So differentiation of y will be what? dy by dx. Correct? Okay. Moving on to the next step. I have ey common, so let's take that common. Let's take that common. Okay, again one thing I forgot. This is 1, right? Differentiation of 1 I have to do, no? I have taken differentiation of entire equation. I have taken differentiation of entire equations. I have to do for 1 also. 1 is going to be 0. Okay? 0. Alright. So let me take e power y common. I get 1 plus x plus 1. Okay? 1 plus x plus 1 upon, okay, dy by dx multiplied with this equal to 0. Okay, now if I move this e power y over here, it will become what? It will become what? 0 only simply. So what I'm gonna get? So check here, 1 plus x plus 1 dy by dx equals to 0 upon, don't have to write this but I wrote it anyway. Okay, 0 upon e power y. What's my next slide? 1 plus, so basically I can keep this over here, bring that 1 over there, so it will become 1 plus x to the time multiplied with dy by dx equals to minus 1, bring this over here, I get what? dy by dx equals to minus 1 upon 1 plus x, yes or no? Yes or no? Okay, let me do the square part first here. Square of this will be what, bacha? Minus 1 plus x the whole square, turn out to be 1 upon 1 plus x the whole square. Please check. I did this part first. dy by dx square I have done first. I got it as 1 plus 1 upon 1 plus x the whole square. Now what is the next step? They are asking us to find d square y upon dx square. I told you how to do it. Simply this, d by dx of the derivative of dy by dx. How much is that? d by dx of derivative of dy by dx is how much? Check here this part, minus 1 to the power upon 1 plus x. Okay, 1 plus x, correct? Let's do it over here. What I'm gonna get? This differentiation as, I have to use what rule here? Quotient rule I have to use. So keep 1. So I have to do differentiation of 1 first. Quotient rule. First differentiate the numerator and keep the denominator as it is. So I'll keep 1 plus x as it is and I'll differentiate what? Minus 1. Then I'll do minus sign. I'll keep minus 1 as it is and I'll do what? Differentiation of 1 plus x. Correct? Next, what is going to be? The square of the denominator. Next, what's going to be? X square of the denominator. Please check here. This is simply 0, right? 0, no? Differentiation of a constant number minus 1 will be 0. Okay, not visible, sir. Okay, all right. Let me change the ink color. This is 0, bacha. This is 0. So this whole thing is 0. 0 here, and minus of minus will become plus. What is this going to be? Simply 1. How, sir? Differentiation of 1 is 0 and differentiation of x is 1, sir. Differentiation of x is 1, sir. This is 1. So I'll do 1. What is denominator? no change, no change. What is my final answer? D square y upon dx square is equals to 1 upon 1 plus x the whole square. Please check. Please check here. dy by dx the whole square is this thing, and d square by dx the whole square is this thing. It means what we have proved, that this statement dy by dx the whole square is equal to d square y upon dx square. That's my answer, right? They asked us to prove this and I proved it. Okay, we proved it, sir. Yes sir, correct. This came as 1 upon 1 plus x square, x the whole square, and this came as 1 upon 1 plus x the whole square again. Okay, let's move on. Let us move on, sir. Okay, now this problem, log of, okay, seventh problem, log of log x is there, log of log x is there. How will we deal it? How will we deal with it? Please see. Again, what we're gonna do? This simple chain rule, right? Simple chain rule, correct? So I will use here dy by dx as what, bacha? First this log will apply, right? So I'll get it as 1 upon log x, but again this will be applied, right? So I'll get it as x. So what is my answer? 1 upon x log x is my first derivative, is my first differentiation of first derivative. Now what I'm going to do next? D by dx of dy by dx, correct na? This is my second order derivative. This is how we write second order derivative. So this will be simply, what is going to happen here? Differentiation of this thing, 1 upon x log x. Yes or no, sir? Yes or no, sir? Yes, sir. What rule again? First you have to use quotient rule, then product rule. Why, sir? See here, for this whole fraction I have to use quotient rule, and for this x log x I have to use what? Product rule. No, because x times log x is there. Okay, so let me do it on this side. So I can write simply this as d square y upon dx square is equals to, please check here, I'll differentiate the numerator first. So I'll keep the x log x as it is, x log x as it is, and differentiation of the numerator, which is 1, minus sign, keep 1 as it is, and differentiation of x log x upon this whole thing, forgive me, this whole thing, not over here, this whole thing divided by x log x the whole square, x log x the whole square. How, sir? Denominator is square, right? Quotient rule. Okay, please check here, this will be 0, right? Because constant differentiation is 0, so this is 0, I don't have to write it. Now how will this look like? So minus sign, 1 will be just simply, I don't have to write 1. Do the product rule over here. So x I'll do first, so it'll become 1 times of log x, okay, and then I'll keep the log x as it is. Okay, I did for x, right? So I did for x first, so it came as 1 times of log x, then I'll keep the x as it is and do for log x, it'll be 1 by x. Please check. Okay, x log x the whole square. What is my final answer? D square y upon dx square is nothing but, please see this, x and x goes out. I have this as minus 1 plus log x, correct na? This is 1 and plus log x upon x log x the whole square. My final answer. Please check here. Minus 1, one second, minus 1 plus log x upon x log x the whole square. This is what? My second order derivative for given function, log of log x. Please understand this. This is my derivative, 1 plus log x minus 1 plus log x minus of 1 plus log x upon x plus log x the whole square for my given function log of x. Second order derivative is defined, sir. I hope this is clear and you can see this entire thing. Okay, sir. Question number 8. Question number 8. Very simple problem actually. Simplest of all, sir. You'll see. I think if I give you a minute of time, okay, you'll solve it in your mind also. Okay, correct na? We have to take the what? Second order derivative. Okay, think here, 500 is a constant, it will remain as it is, e power 7x is there, I can take 7 once, correct, because if for e power 7x it will remain as it is, I'll take 7 out, it will be 7 multiplied, over here also I'll multiply with minus 7, so 7 is a number. Again if I do second order derivative, I'll do another 7 multiplication, it will become what? 7 times 7 will be 49, so obviously it will be true, but we have to show it, let's show it anyway. If you want to solve it from your side, pause the video, solve it, then come back for the solution. Okay, so how will I do it for dy by dx? Please check here. 500 will remain as it is. E power 7x, differentiation will be e power 7x and multiplied with 7. What about this, sir? Same way, 600 will remain as it is. E power minus 7x differentiation is e power minus 7x only, sir. And what is going to be multiplied over here? Minus 7. How we are doing it? Chain rule. I have to do for the exponential function, then I have to do for polynomial 7x also, no? Exponential function e power 7x will remain as it is, then do for polynomial 7x, will come as 7. Same way will come as minus 7. Am I right? Yes. Okay, let's proceed again. So can we take 7 common? Just take 7 common. How much we get? 7 here. What is left now? 500 times of e power 7x, and over here will become minus, no? Please understand this. Minus sign, I have taken only 7 common. Only 7 I have taken common. So minus will remain here only, right? Yes, sir. Let's do the second order derivative quickly. Okay, keep the 7 as it is. Now I'll do what? Keep 500 as it is. E power 7x will become e power 7x. Differentiation is the same, but I'll multiply 7 once again for the 7x part, because 7x differentiation is just 7 and minus sign 600. E power minus 7x will remain as it is. I'll do again what? Minus 7. Please check. I can take 7 common. This 7 will come out. This 7 and this 7 will come out as 7 was already here. 7 times of 7. How much is it? Please check. 500 e power 7x, and this minus and this minus will make plus. So 600 e power minus 7x. How much is this? Please check. The function y only. 500 e power 7x plus 600 e power minus 7x. How much is that, bacha? 49y. 49y. Answer hai. This is the answer. Correct? Very simple problem. Simplest of all, sir. Why did you take it, sir? Because in the exam, not only difficult question comes, sir, simple questions also come. So you should know this is present in your syllabus as well. Okay? Okay? Ninth problem, sir. Ninth problem, sir. This is a good question. You'll see. So first you have ax square plus 2hxy plus 2b plus by square given equal to 0. Okay? They asked us to find what? Asked us to find what? Second order derivative. Again, what type of function is this? Implicit function. Means I can't have just value of y. So look at the previous question. I have value of y. So explicit function is given. Y can be written explicitly in terms of x. Okay. But in this situation, it's not an explicit function. It is an implicit function. So that's why we have to do some modifications over here. Let's see what we can do. So first, what we can do is we can rearrange to find some y and x terms. Let's see how can we do that. So I can factorize it. I can factorize it. Let's check it out if we can do it properly. So this will become ax square. I'm rewriting this whole thing. And this has hxy plus hxy I'm doing. And this is simply by square equals to 0. Why I'm doing this, bacha? Because you check here, I can take x common, I can take y common. Take here x common. What is this? Ax plus hy. Ax plus hy. Again, what I can do over here? Y common. Hx plus by equal to 0. Understand this? There's a h here and there's a b here. Should not look alike. H and b. Okay, I hope it is clear. H and b. Let's do one thing. Bring this term over here. Bring this term over here. I get what? X times of ax plus hy equals to minus y times of hx plus by. Okay. Now bring the bracket over here and x over there. What I'm gonna get? Ax plus hy upon this we bring here hx plus by. Correct? I brought hx plus by over here. Is it multiplication, right? It will become division, comes in the ratio, and will become equal to minus y upon x. Please check here. Minus y upon x. So this is my one of the result that I'm gonna use in to solve my problem. Okay, simple enough. Simple enough. Now what, sir? Of course I need to do the differentiation, no? Because I am looking to do the differentiation only. So how will I do it? Please check. I'll differentiate this statement which they have given initially. I'll do the entire equation. Okay, for 0 it will be 0 only, because differentiation of a constant number is always 0. Even for 0 it will be 0 only. If I do that, what am I going to get here? Please check for this term. I'll get 2, a will be outside, so 2x, correct, is a constant. What about this? So I'll again have to use what here? I have to use what? I have to use, sir, 1 second. I have to use the product rule, no? Because x and y is there, x and y. I have to use your product rule. So keep the 2h outside and check this out. Once I do for x, so x will become 1, so y times of 1, okay. Now if I keep x as it is and do for y, I'll get what? dy by dx. I hope this is not confusing anymore. Please see. For x differentiation, I got 1, y kept as it is. I keep x as it is and do for y, y differentiation is dy by dx. What about this, bacha? Simply b times of 2y. Okay, is it right? I don't have enough space over here, so I'll do below. Okay, this is a plus sign. I'll do here. So see, check here. B will be as it is, 2y. Is it enough? Is it right? No, sir. I have to do for y also, no, chain rule. Y square was 2y. What about y? Now I can write this equal to 0. Now please simplify. This is my first step. What about this step? Please check. I can write this as 2ax. Okay. What about this? 2hy. What about this? 2hx. 2hx dy by dx. 2hx, 2 times of h times of x, 2hx dy by dx plus 2by dy by dx equal to 0. Please check here. 2v by dy by dx. Now I will keep these term over here only. Okay, and I'll bring this term over there. Please check. Okay, so if you want one thing, let's just do one thing. I can cancel this 2, this 2, this 2, this 2 with 0, because if I take the 2 common and bring on the other side, it will become 0 by 2. Simply 0 by 2 is 0, so I'm cancelling this 2 entirely. What will my next step look like? Please check here. Ax plus hy plus, what is it? hx dy by dx, hx dy by dx, by dy by dx. Zero equal to 0. Am I right? Yes. Now what did I say? What did I say? Bring this dy by dx, keep as it is, and bring this over here. So I'll keep dy by dx as it is. So I'll get what? Take dy by dx common. I'll get what? hx plus by. Hx plus by. And this will be equal to what? Negative sign of ax plus hy. Correct? No, because I have moved both of these terms on this side. Both of these terms ax plus hy on this side of the equal to sign. So I get minus ax plus hy. Okay. I'm looking to find value of dy by dx. I get what? Minus of ax plus hy upon what, bacha? Hx plus by. Something, if you can you see here? What is this? Ax plus hy upon hx plus by. Ax plus hy hx by. Ax hy hx by. That was minus y by x, no? That was minus y by x. So I can replace this whole thing by minus y by x. Please see. This minus sign is out. This minus sign is outside. I have to take this for minus y by x. I took it as this again will become plus. So I get what? I get dy by dx is equals to y upon x. Y upon x. Okay. Now please see here. I'll do what? Second order derivative. D square y upon dx square will be what, bacha? Differentiation of this. Correct. So how will I do it? Again, what I have to do? Quotient rule. So keep differentiation of y first. So I'll do what? dy by dx, keep x as it is, minus keep y as it is, and do for x, which is how much? 1. Correct, right? Please check. Please check. I keep y, for y I did first, so I got dy by dx. I kept x as it is. Okay. Then I kept y as it is and do for x. X was how much? 1. X was how much? 1. And how much is this? X square. How much is my dy by dx? Please check here. Dy by dx is how much? Y by x. Yes, no? dy by dx is y by x. So I can replace this dy by dx by y by x times what? X minus y upon x square. Please check here. X will cancel each other. I'll get what? Y minus y upon x square. How much is that? 0. So what is my second order derivative? My final answer. Second order derivative is d square y upon dx square equals to 0. Why, sir? Because I can replace this dy by dx because of this here, y by x, x and x cancel, I get only y minus y is 0, so answer is 0. Answer is 0, sir. So this is nothing but equals to 0. Equals to 0. I hope this is visible. Everything is visible, right? Yes, sir. Okay. Alright. Okay, question number 10. I think the last problem of the day. Yes. Okay, this is a very good question. Very good question, sir. How, sir? Let us see. You have to apply log here, bacha. Why log? Remember in the previous session I said whenever you find a question which has product, power or quotient, I can use what? Log on both sides. Why, sir? Because there is a power rule in log, quotient rule in log and product rule in log. I have a power here. So how will I deal with it? So apply log on both sides. I'll get what? Log y equals to log of x to the power minus x. X to the power minus x. Bring this over here. On the power rule, okay, I get log y equals to minus x log x. I want to find what? Second order derivative. I want to find second order derivative. What I'm going to do? Differentiate this equation. Please try. I get it as 1 by y. Log of y differentiation is 1 by y d by y dx. d by y dx. Yes, and this will be what, bacha? Please check. I have to use what here? I have to use product rule, no? So I'll keep minus sign outside, and this will become what? Please check. I'll do for x first, so I'll get it as 1 times log x will be kept as it is. What I'm going to do for next? I'm going to keep x as it is and do for log x. So simply upon x, x and x goes out. How much is that? Please check. How much is that? Minus, this is log x plus 1. Okay. I want to find dy by dx, so I can simply take the y on other side. So dy by dx will be equal to minus y. This y is in denominator, goes there, minus y times 1 plus log x. 1 plus log x. Is this the final answer? No, sir. Not the final answer. Why, sir? Because they ask us to find second order derivative. So let's see here. Minus y 1 plus log x. Okay. Correct. How will I solve this? Simply take this d square y upon dx square. I get it as, I have to use what? Should I solve it on the other side to have more space to work around? Yes. Okay. Let's check here. How will this be? I'll keep minus sign outside. I'll do for y. What will y become? Please check. Y will be dy by dx. Y will be dy by dx, correct? And I'll keep 1 plus log x as it is. I've taken product rule. Y will be dy by dx and this will be as it is 1 plus log x. Next, what I'm going to do? Take a plus sign, keep y as it is, and do for 1 plus log x. So for 1 I will have 0, for this I will have x. Please understand. For 1 I will have 0 and for log x I will have 1 by x. Please simplify this. I'll get it as minus sign dy by dx, okay, 1 plus log x, okay. What next? Simply y by x plus y by x. Yes or no? Y by x. Yes, sir. Okay. Now please check. What is my dy by dx? This value. Please check here, from here. Okay. So I keep the minus sign over here. Okay. I can rewrite the rest of the statements over here. Please check. I got this as, okay, this step. I'm going to continue from here. Simple, right? Okay, I'll keep this minus sign outside only. Okay, dy by dx, this expression is there, so I'll write it here, minus y times of 1 plus log x, okay, times of 1 plus log x, okay, plus y by x, correct? The same thing, this is the y dy by dx, this is my 1 plus log x and plus y by x. I have y and y here, I can take y common, take y common, it will be minus y outside. Now what I've left, 1 plus log x the whole square. Please check here, I had y here, I had y here, correct? I took y common, it became minus y. This is simply here, there's a minus sign over present here, minus 1 plus log x the whole square plus 1 by x plus 1 by x. Can I simplify this? What is the y value? Remember this, x to the power minus x, 1 by x minus 1 plus log x the whole square. This is my final answer. Let's hope this is correct. Okay, please check. Let's cross check the answer. Minus x to the power minus x, how sir? Because y value was given as x to the power minus x. Okay, so minus sign is present here, so minus will remain as it is. X power minus x, 1 by x I've taken first because there's a minus sign here. 1 plus log x the whole square. Please check. Any option? Okay, okay. So I can take 1 plus log x the whole square, this will work. Okay, 1 plus log x, x power minus x should be there. Okay, it's a mistake, x power minus x should be there and there should be a minus sign over here. Okay, now I can actually rewrite like this also. Please check. No, that's the correct answer. Let me just reframe it. Okay, okay, 1 plus log x the whole square minus 1 by x. Please check. 1 plus log x the whole square. Okay, I can take this minus sign inside, no? I can take this minus sign inside. If I do that, I'm going to get what? I'm going to get x to the power minus x, okay? And this will be 1 plus log x the whole square minus 1 by x, minus 1 by x. So if I'm taking this minus sign inside, this becomes negative, this becomes positive. So only this part. Please check here. Only this negative will be required. X power minus x, x power minus. Please make this change. Please make this change. This is minus x, x power minus x. Okay, 1 plus log x the whole square minus 1 by x. Option B is correct answer. Option B is correct answer, sir. Okay, all right. This was it, bacha. This was it, sir. I hope this is visible. Please check. Please check. Okay. So this we have concluded our continuity and differentiability. Okay. Next, I am coming again with the same chapter. I want to revise one session, everything, because this was a lot of concept. And moving on in calculus, I said everything is very important. A lot of questions are coming from this topic. So I wanted to have a small revision. I'll take, basically, I want to take more questions. This is not the end of the chapter. I will do a revision. Okay. I will do some PYQ questions also before going into the mock sessions. So make sure that you are present in all the sessions. Okay, so far we have completed all the topics, okay, which was required for our completion of the portions, but we will also do some more questions because I want to do, I want you to be comfortable in the chapter, and that can only happen if you have solved varieties of questions. Okay, so I hope you are doing that. I hope you are solving all the questions with me. If you think I am going faster, comment in the section. If you think it's okay, if you are lagging behind in any particular question, pause the video, go back, solve the question, then come here and see the solution. Okay, I hope this is clear. I hope you are working really hard. Okay, maintain the smile on the face, maintain the positive energy with you. Whenever you have time, do some activities, go play sports, but don't spend a lot of time there. Come back, watch the sessions, learn your subjects, and I hope you are all motivated. If you need any help, make sure that you need to about the academics, comment below, get interacted with me, get connected with me. Okay, all right, with this I would like to end the session for today, and take care. Bye bye.